words. So this is my colleague Cam Sargent and myself, Amanda Chow, and we're both from the Department of Math and Statistics. And we just want to welcome all of you for coming tonight on this really cozy Monday evening. So welcome. This event is being put together by the Center for Indigenous Knowledge and Languages and our department, the Department of Math and Statistics. And we're really excited to have our very special guest that the Associate Director of the Center in a moment will introduce. Right, so this event has been funded by numerous units in the university, our department, the Faculty of Science. We also received funding from the Provost Office. We had a special Indigenous Teaching and Learning Fund. So we want to acknowledge them and thank you for their contribution and support. And I'm going to now hand over the mic to this gentleman here, who will probably introduce himself.
Yes, thank you to them and Amanda and Natalie, who's here as well. I wasn't moving. Okay, there we go. Hopefully I'm holding it really late. But a lot of work has gone into organizing this event, and we were so thrilled to have the incredible turnout. So thank you to everyone who's come out tonight. I wanted to begin with the land acknowledgement for York University. So just to remind everyone that York University recognizes that many Indigenous nations have long-standing relationships with the territories upon which York University campuses are located that precede the establishment of York University. York University acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaranto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Nation Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. This territory is subject of the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. My name is Brock Wanaput. I'm the Associate Director with the Center for Indigenous Knowledges and Languages and also the coordinator of the Indigenous Studies program. I have the honor of introducing my friend and colleague, Ed Doolittle. Dr. Ed Doolittle is Gunyan Geauga of the Flint Nation, Mohawk from Six Nations in Southern Ontario. He earned a PhD in pure mathematics, partial differential equations from the University of Toronto in 1997. He is currently an associate professor of mathematics at First Nations University of Canada and at the University of Regina in Regina, Saskatchewan. And tonight, the title of his lecture is Indigenous Maths, Global Math, and Indigenizing Mathematics. So please join me in welcoming Dr. Ed Doolittle.
Sorry. Oops. How was that? Can you hear me? Okay, excellent. All right, thank you so much. I am so glad to be here. This is where I grew up. I'm from Ontario actually, but went to school in Toronto, at the University of Toronto for 12 years. And it's really, that's the very last slide, I think. Yep. Something's on that. Yeah, sort of the slide back. I'm so pleased to be here. I have not been home since COVID started, since 2020, last time. 2.5 years I haven't seen my family, and it is a real pleasure to be surrounded once again by family and friends and colleagues in person. I consider myself blessed that I have this opportunity Yeah, there we go. There's my perfect slides. Thank you. I'm going to try to control the slides from here, but it's a long distance and my foot piece, so maybe or maybe not. We'll see. I'll walk around with this as a giant remote, so kind of comical. Yeah, I tend to move around a lot. Okay, I'm cutting in and out. I'm not sure if I've got something wrong here. Should I adjust this somehow? Maybe hold my hand. Okay, it's been popping when people do that. I'm going to try this, and we'll see. I detect it's cutting in and out, but anyway. Yeah, this is so my mother's cell phone. Yeah. Anyway, so it is a great pleasure to be here. I want to give you a talk about Indigenous mathematics, but I wanted to put it in context, which is very popular. Yeah, it's cutting out again. Just keep talking. Sorry? Yeah. So I'm going to switch to this mic. Can we maybe switch to this one? Because I think I'm a little worried that if you're recorded, we'll be all messed up if this continues. So let me just my register. Is it live? Okay. Thank you. So I am going to try to stay too much. I just tend to walk around, so maybe that habit I should try to break anyway. So she's over here. All right, here I am. So I am a mathematician, and one of my lifelong interests is in indigenizing mathematics. We didn't use that word back in the 1980s, but mathematics, I thought of it in terms of teaching mathematics to Indigenous students. So I think we've come a long way in thinking since those days. So what I want to talk to you about today is the things I've been thinking about and trying to sort out. It's a genuinely perplexing topic. And I would say it's one of the hardest things that it's one of the hardest things that I've done in my career. And I tried to seek out difficult things to do. So when I studied mathematics, I wanted to study something difficult in the university, partial differential equations. And I can see, to me, it's something. And I would say Indigenous mathematics and Indigenizing mathematics. Of course, I'd say something about me as well as the topic, but it is a perplexing, difficult topic. And there are a few guides in this topic. So those of us who are working in this area are producing things from scratch. Part of the reason for that is, of course, residential schooling. That we have lost so much. We have lost terrible enormous amount from residential schooling. And residential schooling really has an active role situation. And it is a particularly acute and active role. If you think about what was taught in residential school, there were really three things that were widely universally taught, maybe four only. Because they did a very poor job at school in residential school. But they did, of course, with indoctrination, and they taught English or French, the language, with the notion of stamping out the indigenous language. They taught Christian religion of some variety, and that's the idea of that was to stamp out indigenous spirituality. They taught farmhands. They taught that one end of the farmhands domestic But there was one more topic, and that was mathematics is widely taught in residential school. And I don't think anybody really understands what happened. So, you know, the idea of teaching English and French was to stamp out the language. The idea of teaching the Christian religion was to stamp out spirituality. What was the mathematics supposed to stamp out? And I believe that there is an indigenous mathematics that perhaps was used as a fact, just like indigenous languages were, and just like indigenous spirituality. There are indigenous mathematical ways of thinking. And the idea of teaching mathematics that was taught in residential school was to suppress indigenous mathematics. This is my theory. Now, I think a lot of work needs to be done. This is a question that I've not really seen addressed. I have done active searches on this issue, and I found a couple of works, theses, and so on. But very little has been written about this, and I think it's a place for some active investigation. We are in a bad position because very few indigenous people are comfortable with it. So that means very few of us are ready to address these issues. It spreads us all very thin. But if you are so inclined, I would suggest something interesting topic to consider. What was the role of mathematics education in residential school? Anyway, I wanted to tell you a little bit the title I chose. So I chose the title for this talk. And you see what the word math appears about in three different guises here. And this is quite deliberate. That you talk about Indigenous Maths. So I use the word maths. I counted the word maths because I'm working a lot with Australians and Australian Indigenous people and so on. And they say maths as the short form of mathematics. And the same thing in the UK, people say maths. So you say, I went to school, I say maths. And that's just a short form. But to me, it sounds plural. And that's kind of why I adopted that. Because it is plural. It is a plural. The thing about Indigenous anything is that there isn't just one. There are as many as there are nations in the world. Thousands, tens of thousands, different Indigenous Maths. And so that's the first thing we have to learn from. And that's why I very deliberately chose to do it. So I got a very small slideshow. This is not a particularly vibrant slideshow, but it's just a few variations on this item. And I call it the cultural mathematics trilateral. So the few things that are happening here, these words are very carefully and deliberately chosen. Cultural mathematics is a way of thinking about the mathematics of Indigenous people. And so there are different terminologies used for this. Sometimes we talk about Indigenous mathematics, cultural mathematics, sometimes ethnomathematics, and so on and so on. I find the word cultural mathematics, the phrase cultural mathematics, to be neutral enough for us to work with. I don't like other words that we may use, and we will tell you a little bit about them. Cultural mathematics, I find, is something. Trilateral. Can anyone tell me what a trilateral is? Yeah. Yeah. So trilateral just means three lines. It's fancy and a lot. But this thing, the shape, this yellow shape, you give it a different name, right? Triangle. Okay, so it's not a hard math question. I'm not really putting anyone over there. It's a triangle. No, I'm calling it a trilateral. Why am I calling it a trilateral? Am I just being difficult? I just feel contrary. Well, no, there's a definite reason for this. And so another part of what I'm trying to do in this Indigenous mathematics thing is to make it into a subject that people can talk about and we can have university courses in. One of my dreams is to have a business card that says Edward Doolittle professor of Indigenous Mathematics. I wanted to become a thing, subject. And part of what a subject is not just a particular bit of knowledge about this or about that, but there's a whole tradition. There's a stories, there's the people, the characters, and the development of it, so on. And that's where the word trilateral comes from. So I'll tell you, it comes from a story. One of the first conferences that I was involved with, sponsored by the CMS, Canadian Maths Society, Montreal. So I traveled to Montreal, met with some of my colleagues, and everybody talked for a little while about these mathematical issues. A long time ago, so this is the early days of mathematics. One of the speakers was Louise Poirier, who's now a full professor of math education for University of Quebec, Montreal. Actually, sure, it's only one in the club. She gave a talk, and she said her talk was about math education issues in Northern West. That we will bring, we will try to improve the math education. What comes from Northern Quebec? Don't know what to do. Really don't know what to do. So they thought, okay, here's an idea. We'll try to translate the curriculum into Cree. And so they took the Quebec mathematics curriculum, went out from bilingual, trilingual speakers, and started trying to translate it. And she said it was not a success. It seems like, it should be step one, but even that stymied. One of the problems that they ran into was that they needed a Cree word for the word triangle. And so they talked to one group who said, yeah, a triangle is something with 3 points. And they talked to another group very close to the first one. They said, no, a triangle is something with 2 sides. And so they had different Cree words. One that kind of captured the meaning of 3 points, and the other one had one that was 3 sides. And this was just emblematic of the entire effort to translate the curriculum into Cree. And so they eventually abandoned it. They could not come up with a standardization, which is what a curriculum is. It's kind of a standardization, sort of like metric is a standardization. A curriculum is a standardization. They could not come up with a standardization or that would satisfy all the Cree communities. And so they had to abandon it. And so to honor that, I am calling this figure with 3 sides, not a figure with 3 points. Figure with 3 points would be a triangle. Figure with 3 sides would be a triangle. That's why I use this rather unusual word triangle. It turns out they're really the same thing, mathematically speaking. If you've got 3 lines, they define 3 points. If you have 3 points, they define 3 lines. So they're really essentially the same. But there is a difference. And I was talking with the great Canadian mathematician Richard Guy, who took an interest in these indigenization issues. We met with him many times down. He was like 99 years old. Anyway, I was talking to him and I said, quadrilateral. He said, no, they're not the same thing. They're not. A quadrilateral has 4 sides, 4 words. But that makes 6 points. And a quadrangle has 4 points between 6 lines. So they're not the same when you talk about 4. Quadrangle and quadrilateral is really quite different. But triangle and trilateral. Anyway, that's just like I said, I'm trying to develop a tradition around this, discipline, study. And part of it is the stories that we have, the stories and stuff. And so I'm trying to remember this by the language that I choose, trilateral. So maybe it's precious, but I'll give it a try. All right, so there's my Indigenous Maths. And so the word trilateral reminds me that there's more than one math, that there are many Indigenous maths. Each Indigenous nation, each community has its own math. So there are multiple Indigenous maths. And there are many other reminders of this. Now, this presents a difficulty in terms of standardization. It seems to make it more difficult for us to proceed because standardization tends to amplify ourselves. So I learn the metric system. Well, I don't have to learn a new measuring system if I go to France, if I go to UK, if I go to Japan. I use the same measuring system. So I spend less time learning these things and more time learning whatever interesting stuff I have to do with it. But that is not point of view shared by many Indigenous people. To give you another example, Mohawk language, I learned Mohawk language. I still need to learn much more, but I spent 40 hours a week for 40 weeks in immersion. So, when we talk about you all of us, we can talk about us too, or we can talk about all of us, and instead of one first time we say us too, so we can all converse in Mohawk. So I do have learning Mohawk too. Anyway, I was reading a book, a little report actually, from the Ontario government in Mohawk language. The Ontario government tried to standardize Mohawk spelling. Probably 2 or 3 decades ago. Again, 9 different Mohawk communities, 9 different standards for spelling. That's no standard at all, right? So, but that's just the way Indigenous people are, at least Mohawk people. They're stubborn. All stubborn. So, and that's not to say that we say you're doing it wrong. We don't say that. We say, this is the way we do it. And if you do it a different way, that's the way we do it. That's the understanding. So we're not going to try to force our way on you. We don't try to force our way on. And so we are not going to succeed if we have the wrong idea about what Indigenous mathematics might look like. And I see this as a problem many of my colleagues have. They say, well, let's do the national Indigenous math curriculum. And I'm sorry, I have to shoot that down right there. There is not going to be ever any such thing. It won't be true. It won't be real. If it's national, it won't be ours. Every Indigenous community has to do their own mathematics. And so this puts a burden on us. It says that we have to do some work on this. Every one of us, every single Indigenous person has to work on Indigenous mathematics, has to learn something. I would say it's exactly the same as language. There's a burden on us. The generations and things that have happened in the past have now placed a burden on us. We need to work hard to carry our languages forward into the future. I took a whole year out of my career development, where I could have been, racking up time, earning tenure, raising my salary, but I didn't. I took a whole year off of my career to learn language. So it was a moderate sacrifice on my part, but it was absolutely necessary, absolutely worth it. I would say it's very similar to mathematics. And that's, people say they want to do something in Indigenous mathematics. It's kind of a test. I get that. Would you learn language? Would you learn an Indigenous language? Would you be able to put that effort into it? Then maybe we can start to develop Indigenous mathematics. That's not to say there's no role for anyone else. We can accept help from anybody. But you want to start developing Indigenous mathematics, I think you've got to put the time in. You've got to put the time in to learn about your local community, how they do things, how they understand things, how they think, what their traditions are, and start to look for what is mathematical in that community. And it will vary from one community to another, and it will be contradictory from one community to another, and we have to learn to accept that. So this whole business about standardization, I think it's a trap. It causes us to think in a way that's not truly ours. So we must be careful about it. It is a little bit disappointing. Remember when I was learning Mohawk, they talked about how to say how something weighs 5 pounds. We got Wutsara. Where does that word come from? Wut comes from pound. There's no P in Mohawk, so it changed to a K. So 5 pounds. I said, well, how would you say that in metric? They just like, Eddie, was, get out of here. They don't do it, we don't do metric. So I can just imagine the metric T2 exactly tenfold. So yeah, so there is Indigenous math. I spent a lot of time on this one. Slide one. Okay, that's it. Let's go to slide 2. That's global math. My next slide. My next word here. So when we talk about Indigenous maths, we end up talking a lot about the other side. What is the other side? And you'll see the term Eurocentric, or sometimes, or very often, probably more often, you see the term Western science, Western. I abhor that. I hate it. It's not, it comes from an old, incorrect frame of view where people divided the world into 2 parts, the Occidental, the mysterious East, where those mysterious Chinese people live, and the Orient is where the Chinese people live, and the Occident, the Europeans, the Orient and the East and the West. And so the rational is the West, the mysterious side of life is from me. And that is just wrong. It can be utterly dysfunctional. A book you can read about this is very difficult but very rewarding book by Edward Said, Orientalism. And so Orientalism is taught as a subject in universities for many, many years. It's frankly become passe, but John Mohawk, who I was chatting with him here too, said that he sees same problems that we have in Orientalism, that we had in Orientalism with Indigenous studies. Indigenous studies could become a study of the exotic, of the mysterious, and really do us that much good. So anyway, I abhor Western mathematics. I abhor Western science. That sort of thing. And people who talk about Western this, Western that, they draw the line where there's convenience. So Russia's now the East, so versus the West. And I don't see that as appropriately useful terminology. So I abandoned that, try to think of an alternative way of global mathematics. And I think a global math. And this really is suitable, I think, that we talk about globalization in many ways in modern life. We have global economic system, we have global labor, we have global financial systems, we have global trade. And people who are active in these areas know that there are associated issues with globalization. That, for example, we have kind of a homogenization worldwide of the things that are available to us. There is a kind of a worldwide leveling of labor and environmental regulations and so on. So globalization has been an issue for us. I believe that global mathematics is exactly the same vein. That what we are dealing with is not a Western, not a European phenomenon, but it is now a worldwide phenomenon. The mathematics, my test for this is, could I go somewhere else and teach mathematics? And the answer is absolutely yes. I could go to the UK, I could go to Australia, I could go to New Zealand, I could actually come get on in French too. So I could go to France, I could go to and teach undergraduate mathematics without any trouble. Just pick up the textbook. You probably even do it from memory and start teaching. And the students would generally understand all this. So mathematics is a truly global phenomenon, and it has many of the same issues and problems that global phenomenon of all kinds. And so the mathematics that is often taught in universities and even in K-12 schools is global mathematics. And that sets up a nice dichotomy between the indigenous and the global. Because that is really what indigenous means. It's the opposite of global. Indigenous means indigenous is particular to a particular locality, particular place. And when you say indigenous, it's rooted in place. Whereas global is not. Global is kind of So there really is kind of opposites. So I really think that these are appropriate terms. I have not yet to get many people to agree with me. So I'm trying to proselytize this. But I urge you to consider these issues. What is the opposite of it? I see it. Yes. There's there are many other words here. There are many texts that choose better words than Western. So one is not, you see, merely universal intervention is another way to say it. That's what I say there's more civil. Alan Bishop, writer in this area, uses the capital M method. Called capital M. I don't know what that is. It gives precedence to it. And I don't think we necessarily need to start off the wrong foot. So there are other options. I'm going to suggest that we can use it. And the third side of my trilateral is indigenizing. So just to be funny about this, I know I chose maths there and I chose math there, so I thought, well, indigenizing is a long word, so I'll use the full word. That's the and this is like a third thing. Originally, I put this in the space between global and indigenous math, but now I'm starting to think of it as a thing in and of itself. It's sort of a third thing. So that's really quite a lot. But indigenizing mathematics is something we do in universities and maybe in schools, and it's not indigenous mathematics. So that's why I distinguished it. It's not indigenous because it's more closely, I guess, associated in my mind with global math. Is that we have some kind of global math that we want to teach, and we want to flavor of indigenous people in it. We want to make it more palatable for indigenous people. We want to do something, even though we are still very stuck in this curriculum that we have. Teaching mathematics at First Nations University, I have to integrate with the University of Regina system. Because our students take courses with me and then they go on and take the U of R course. So I can't just do my own thing. I have to integrate it. So I end up indigenizing that instead of teaching indigenous mathematics, which I might like to be better, but that's not going to be satisfying in terms of my employment. And it's not really not what people expect. So one of the things about global math is that it offers career opportunities, and that's a lot of people dwell on this. I think that there's no need to dwell on it if you're not interested. You don't need to keep harping on how important it is. People will decide that for themselves, right? So we cannot push. We should not push people into doing things because we think it's good for them. They have to come to that notion themselves. So some people, some indigenous communities and some indigenous people have taken up global math because they like it, they find it useful, they find different opportunities, but that doesn't mean that we have to do it for everybody. So we don't necessarily want to force people to do this global math stuff. And I see it all the time. People say, oh, we got a crisis. Indigenous people need to learn math, but they're losing career opportunities. I'm like, who are you to say it's a crisis? It's not your job. It's a political decision. You have to understand that people need to make their own political decisions for themselves. What do you want your young people to do? Talk to many indigenous people across the country about what they want from mathematics. Some of them say, yeah, we want our young people to be doctors, lawyers, engineers, who want to go to the university and be successful. I said, great. And we need to do some global math. I talk to other communities, they say, our main goal is that our young people should be able to survive in the bush. And this is not going to help. In fact, I would go so far as to say it might hinder their survival. Global math, like all the time they waste studying useless stuff in that context. They could be learning many other skills. So those people have to make that decision. It's not our job. not anyone's job except mine. So, anyway, that's kind of what I end up having to do at First Nations University. I teach a lot of global mathematics that I'm indigenized. So I put some flavor, some examples, and I grab whatever I can from various different Indigenous communities. If you're teaching Indigenous math, then you might want to focus on your own community. So indigenizing, I think everything's fair game. Let's just grab whatever we can. It's hard enough to do this without restricting ourselves further. So that's indigenizing mathematics. Yeah. So I just want to talk now about the relationships between a little bit, and this I'm not so clear on, but what is the relationship between indigenizing mathematics and indigenizing? Well, what indigenizing mathematics tends to do, in my experience, is provide a definition for what is math. That we then can apply to Indigenous math and say, search for what is math in this country. So one very successful effort in this is Alan Bishop, who I mentioned before, has given 6 parts of what he understands math to be. And so it's counting, locating, measuring, playing, designing, and explaining. I may not have the order in this meeting. So I think he said counting, measuring, locating, playing, designing, and explaining. Notice that there are verbs and activities in this derivative. They're mathematical activities that all people engage in. So we find counting in all societies. And we can search for counting. What are the number of words? What are the different ways of counting? And similarly with all the others. The playing has to do with games. Games are often structured. There are rules to games. Well, we find structure, we find mathematics. And so Alan Bishop's understanding of this, giving us a definition of what mathematics is. Not a perfect definition. I don't think it's perfect. I don't really get the heart of the matter, but it's a good working definition. Allows us to go into Indigenous and search for these things. The counting, the measure, the locating, playing, designing, explaining, and then what we do with that is we kind of pull it back. We pull it out. We pull it out. Abstraction. So, but I would say that I'm starting to see problems there. I'm starting to see issues. This is not healthy. The situation is not at the moment healthy. I think it can be made healthy, but there is real help here. It would be one way to describe the situation. And so the illness in this case is that the definition now starts to box this in a little bit. This is mathematics, but these other things are not. That would be science, that would be spirituality or whatever. And that is not the Indigenous world. That we think of things in a holistic sense. That we don't really draw these distinctions between subjects. And so this definition of business is actually not quite right for us. So that's one problem here. One aspect of this sickness here. And the other one is the abstraction part. The abstraction is coupled with extraction. And that has been an issue that we have faced all along as Indigenous people, that our lands, our societies have been mined, they have been exploited and extracted from. And that is something that I see in many of these efforts to indigenize mathematics. We'll go into a society, we'll talk this one thing out, we'll say, oh, here's an interesting example of math, and extract it, take it away from the context, take it away from the environment around it, and all the holistic parts that are involved in it. Maybe there's a spiritual aspect, maybe there's and we take that out and extract it and say, here's now a topic to talk about. So that is the problem I see. It doesn't have to be that way. And so I think the sickness that I mentioned can be cured or can be addressed. We can start to heal this. But at the moment, there's possibility for illness. Let me give you one example. So there's a game that Mohawk people play, Teach Stone Boulder. And it's a beautiful example of mathematical thinking. There's some nice mathematics to it. But now I have to be very careful if I'm going to write about this and talk about it, because if I just take it out and say, here are the rules of the game, I'm losing a whole bunch of stuff and losing the context. It is part of ceremony. It's part of the ceremony that takes place at a certain time of the year. It has ceremonial meaning. It was almost lost, but it's been brought back. It's an important part of our ceremony. We find it in our creation story. So there are many aspects to this. Who plays it? Who has the right to talk about it? These are questions that are non-mathematical, and if I simply extracted it, I would not be addressing it properly. So that is just one example of to not just helicopter in, find something, pick it out, and leave it. We have to work with Indigenous people. What is appropriate for me to do at this juncture? Can I write about this or that? So no, lots of work has to be done to get it done. So that is some of the issues here. Let's take a look at the other side. Global Math provides us with a curriculum. Just like in the University of Regina system, I provided with a curriculum. I'm told, here's what you're teaching in Math 101. And I got a little 50-word description, and then the math department has produced a page long document to expand upon. That is what I'm expected. If I don't, I may be doing them a disservice because they may need to move on to the next course. They might be missing something, and then that's really fault. I don't want that. So both math provides curriculum. But again, this curriculum issue is again, it's like a problem as well as a resource. That there may be things that I want to do that are not part of the curriculum. And fortunately, I feel secure in my position as a tenured professor in the University of Regina system, that I can depart from this if I see it valuable and necessary or important. Depart from the curriculum. I feel that I have the personal agency and power to do so. But many of my colleagues, they're junior faculty, they're not tenured yet, they're sessional faculty, they're hired on a contract basis, fired or never rehired again. So they feel and they do stick to this curriculum much longer. And we use opportunities. So there is an illness, I think, here. And this one was hard for me to think, what is the relationship between Indigenizing math and maths? I could not really think of how Indigenizing might influence both. That's one thing about global anything is that they're kind of like they are citadels. They're difficult to assail. And so Indigenizing mathematics has very little ability to change global math. That is a problem. There should be a cycle. There should be cycles here. There should be feedback happening. But it is not happening. Global mathematics is difficult to assail, difficult to change. It is just ticks along on its own. It doesn't care about the rest of us. And so all I can think of is that Indigenizing mathematics provides a service to global mathematics. And this may seem unkind, but I'm going to say what it does is provide cover. It provides cover. It allows global mathematics to continue. We will toss a few bones out here, and then we will get continue to the rest of our tasks as we see fit. So we'll just isolate this indigenizing to an hour a week, and that'll be minimally disturbing for us, and we'll continue with what we have to do. But again, we see a problem. So here, global mathematics and the relationship between global and digital. You see, I'm calling this ethno-mathematics. And the problem I see with ethno-mathematics, I read a little bit in the literature, is that it starts from a position of global math. It says, okay, where can we see this in an indigenous culture? So let's take a topic in global math, Euler's graph. We see this in African Sona Santa. You may see it here. But that is not, that's not the way to see true indigenous math. You're automatically putting on your blinders. You're only seeing what you're looking at. And that's the problem I see with that. It starts from the global mathematics perspective. So we're working to see this in indigenous culture, or we're missing a whole lot of this. And then what is indigenous maths applied to global math? Well, it's the elementary part. It's like, yeah, counting is easy. It's like true stuff. So that's okay. But there's nothing really advanced in indigenous. You don't find advanced stuff. Nothing. Hilbers and Schellen's apps. You don't see that. But there's a problem here. It's a problem of arrogance, basically. So there are traditional values that we have. Humility is one of them. And I know this is an important value in African cultures, and it is in my culture. Humility is important. And so we don't really see that in the opposite. And so there are problems all around it. Illnesses. It's a sick time. And so that's part of what I hope we can learn to address is how to make this a healthy situation. It's a difficult, complex thing. And partly it's difficult because mathematics has been stamped out from indigenous people. We have lost the traditions of it in our cultures. And now many indigenous people think mathematics really is global. The late Narcissus Blood, a prominent member of the website in Alberta, came to Banff International Research Station, and he was reluctant. He declined the invitation first. He said, I dropped out of school in grade 2. So I don't know anything. I don't know anything. Fortunately, his daughter was a school teacher and said, he thought something just come, please, just want to. And he did, and he came every year after that because he realized he had an offer to offer. But one thing he said to me is, I never realized how political this is, how political the movement is. Now I understand. Politics is something we understood better. So yes, so we've got to bring people back into this field. Say, yes, you all have something valuable to contribute. Yes, we need to hear from you. Yes, you have an influence. Very good every day. And you need to raise it up. You need to learn how to teach and learn it and how to carry it into the future. We are reaching a bottleneck, I think, just as the way we are in language. If we don't take active measures, active steps to bring our languages back, we're going to lose it. And I think the same thing with indigenous languages, the danger of losing. For some reason, things pop into my head. I just say, I remember talking, I was in a little math training in Alberta, had numerous indigenous people there. One of the people spoke up and told a story. She said there's this algorithm that lives traditional life, And one day someone gave him a chocolate. And so he opened the chocolate bar and ate it. And it tasted anything like it. Simply sweet or whatever. Ate it. And then he stood there confused. I asked him, what is the problem? And he said, this is the first time in my life I didn't know what to do with something tobacco. I didn't know what to do with that. There is something mathematical about it. Right? And it's hard for me to explain. I don't have a really good definition of mathematics. Alan Bishop's definition is not adequate for these things. But there's something about consequences, future, and part of what mathematics is about to me is not just if I start here and I go this way, where am I going to get to? But the reverse is if I want to get to here, how do I reverse those steps? And that it's hard for me to explain. Reversing things. You see something reverse, like this situation. But this is, good part of Indigenous. I would go so far as to say part of Indigenous, but I think it is, I can't really explain to you exactly what you can explain what's right and wrong. I'm just telling the story. And you pick it up and maybe you'll see something in it that I don't. But something totally part of that story. Anyway, that's all I got. And I think I'm where we're at. I think it's stop.
Too far away from you. So thank you so much for that really words. So this is my colleague Cam Sargent and myself.